Hey Math 2 students, this is Mr. Flynn again. How you doing? Hey, today, April 1st, we're going to be going over factoring again. We're going to hit factoring quite a bit, and then inverse function, which should be a review. Actually, both the factoring and inverse functions are a review, but I know factoring has been giving people some problems, and I want to just keep going over it until we have it good, okay? You need to know your factoring, especially going into the next unit and into Math 3. If you are having any problems with any of these, please email me. I will do my best to work with you, whether it's in the office hours between 8 and noon or after, okay? We'll just figure this out. So I'm going to start with problem number 1, okay? It says factor completely. The first thing we always look for is the GCF, right? That means is there a greatest common factor of each term, the first term, the second term, the third term, and there is no greatest common factor, so we're not going to factor anything out. The next thing we do then, because this is a trinomial, all right? Because it's a trinomial, what we're going to do is we're going to look at this last term for right now. There's going to be another step to it, but we're going to look at that last term, and it's 27, and we're going to list its factors. 1, 27, 3, and 9, and we're done, okay? Now, if you remember, go back to your notes from yesterday. Save those notes somewhere all the time. Always save them because you can use them on any assessment. But if the last term is positive, that means both these factors are going to be the same sign. Oh, S-I-G-N. All right, both the same sign. Then the middle term tells us which sign that is. All right, so that's only if the last term is positive, then both these terms here, these factors here, are the same sign, and then we look to the middle term to see what that sign is, and they're both negative. All right, so again, let me erase some stuff here, get this out of the way so we can kind of see, and we'll just talk about it again. All right, and I'll use a different color this time. I'm going to use this color. So if the last term is positive, we check to see what the middle term is, and then that tells us what sign both of our factors are. And if you remember, the 27 comes from the last term, and we list the factors. All right, 1 and 27, 3 and 9, because they're both the same sign because of that, and they're both negative. Then I have to figure out which one of these two pairs, this pair here or this pair here, will equal the middle term, negative 12. And that's this one. So, because the x squared is by itself, it's just x minus the 3, that one, and then x minus the 9, that one. And we're done. That's it. Okay, if you were to, again, FOIL this all out, you'd get the original trinomial. Okay? I'm going to go to number 2. Number 2, greatest common factor. Take a look at it. Does it have a greatest common factor? Is there something I can factor out of every term? And the answer is yes. And remember, we want the greatest common factor, not just any number that can go into both the 2, the 10, and the 48. But our greatest common factor is 2, so I'm going to take the 2 out. So to figure out what I have left, I have to divide everything by 2. So this cancels, leaving b squared. 10 divided by 2 is 5, so that's plus 5b. 48 divided by 2, 48 divided by 2 is 24 minus 24. So what I have now is a greatest common factor. I always leave that onto the answer, and now I have another trinomial. So now I'm going to factor it. I'm going to factor the trinomial very much like I factored this trinomial. Okay? So go back over here. I take the 24 and list the factors. 1, 24. Can you list the factors? Think about them. Try to be a step ahead of me. 2 and 12. 3 times 8. And 4 times 6. Notice I always list the smaller number on the left and the larger number on the right. It's easiest that way. Now, let's see here. The last term in this case is negative. That means these factors are going to be different signs. And the middle term tells us which the larger one is. The larger one is positive. So I put a positive on the larger ones, a negative on the smaller ones because they're different signs. And now which pair adds up to positive 5b? And that's right here. So then I write that 2, that greatest common factor. And then I have b minus 3. I get that right here. Okay. Close that up. b plus 8. Where did I get the plus 8? I got it right there. And you're done. Pretty simple. Okay? Now, there's going to be some different factoring to do, so please pay attention. All right, I'm going to do number 4 for you. So again, with number 4, look, it's not a trinomial, no big deal, but we look for the greatest common factor. And I look to see, it looks like there's a 2, but there's also a variable. There's a p squared here, and there's a p there, so I can take a p out. All right, so let me get rid of this. Let's start again. So I'm going to divide everything by 2p, 2p. So 2 divided by 2 is 1. P squared divided by p leaves p. Negative 20 divided by 2 is negative 10. And p divided by p, they just cancel out. And I'm left with this. It's not a trinomial. There's no other factoring to do. There, you're done. So sometimes you have to factor, and there's only a greatest common factor. Not every time, but sometimes, okay? All right. Now, you're going to do some of these, but I want to come down to number 8. Because number 8, I'm going to use a different color here. Number 8 is a special case. You're going to start to see this one, okay? We have an m squared, and we have a constant. We do not have an m term. So like usually you'd have m squared plus 3m, right, plus 2, where you'd have that m term in the middle. There's no m term, okay? We only have an m squared, and we have a constant. But what we have to keep in mind, okay, is we're going to rewrite this so we can understand it like this. We're going to write m squared plus 0m. So now we have an m term, even though there's nothing there, because 0 times m is 0, minus 49. Okay? Now, that 49, let me get some space here. That 49, we're going to list as the factors of 1 and 49. 1 times 49 is 49, and then 7 times 7. If the signs of the last term is negative, that means they're both different. All right, so one's positive, one's negative. All right, these two when added together give you 0, right? So we're going to get the m plus 7, m minus 7. It's one of those special cases. And you always know it's a special case when you have a squared variable and then you have a perfect square here. So if I had m squared, and again, there has to be a negative, a subtraction, minus 25, that's just going to be m plus 5, m minus 5. Okay? If I have m squared, right, minus 100, what do you think it's going to be? M minus 10, m plus 10. Okay? I just want you to see that because you're going to start to see these special cases show up. And they're listed as binomials, but you have an m squared term minus a perfect square. Okay? So now I've done 4 of them, and that's your factoring. Now I'm going to move down to number 15. I'm going to start to look at the inverse functions. This, when we did it in class, you guys did awesome at. When we did it on a test, people forgot some things. Really, you have to remember that anything g of x, f of x, h of x just means y. So this is just y equals 5x divided by 3. To find the inverse, switch. the x and the y. Just switch them. So I'm going to put x here. I'm going to put 5y here over 3. And now, that's step 1, switch them, and then 2, solve for y. So now we want to get the y by itself again. So basically, to get the y by itself, let me change some colors here. To get that y by itself, I have to multiply by 3 to get rid of that. And that gets me, okay, 3x equals 5y. And then get that 5 out of there, I divide by 5, right? And I get y equals 3x over 5. And again, this is number, what is that, number 15? We can scroll down, check number 15. Notice how they list the inverse function with that -1 there equals 3x over 5. And that's what we have as an answer, 3x over 5. Okay? I'm going to do one more. I'm going to do number 20. Okay? So substitute the g of x, put a y in there, then switch these. All right, just switch them. X equals -2y minus 1. Now, solve for the y. So we're going to add 1, just like we're solving an equation. X plus 1 equals -2y. Now, watch what we do here. We're going to divide by -2 to get rid of that. Divide by -2. I will be pretty good, probably accept that. But you're going to see multiple choice answers, okay? So really, let's move this up here so you see it a little bit better. If we have x plus 1 over -2, and that equals y, well, let's simplify this. This is x over -2 plus 1 over -2. You never want negatives in the denominator, okay? It's just kind of it's kind of like bad grammar in math, okay? So you can switch it to bring the negative up. You could have a -x over 2 plus -1 over 2. Or you can have -x over 2, because -x divided by +2 is a negative, and then this is -1/2. All right, or you can have -x minus 1 over 2. These are all equivalent to each other. All right, so you really don't want this. I should change colors. And you really don't want this, but I'll be pretty good. I'll give you big time credit even if you get to this point. I'll give you extra big time credit if we can get up here, okay? Those are the answers that I want. So again, this is your work for today. It's just factoring, so we're going to keep hammering that. Please don't forget, we're going to do that, a lot of that. And inverse, that's a review. So if you have any questions, please email me. If you have me 3rd hour, you can email Mr. Files. If you have me 8th, 9th, you can email Mr. Owens or Miss Manglardi, okay? So we're here to help you any day. Have a great one.